Hi Calculus 1 students. Before I continue, this example is meant for section 18. Section 19, we have seen this example in class, okay, with as much detail as what I'm going to present. That being said, nothing prevents you from looking at the video if you want to review that particular example. But this video is really intended for section 18, and I'm letting you know section 18, I will repeat it to you, but I'm letting you know that this has to be part of your lecture notes of this week. Okay, we want to evaluate the limit, and take note here, it's a one-sided limit. So I will actually just note this right away. It's a one-sided limit that we're trying to do of this function. Okay, so 4 minus the absolute value of 4 minus x squared over that thing. Okay, the first thing we're gonna do is to directly substitute. This is really as usual. So, okay, let's go fast first, but not that fast. We still want to see what the inside of the absolute value is approaching. So negative 2 squared is 4. 4 minus 4, 0. Okay, so here you have to be careful. This is a 0. And at the bottom, what you get is negative 1 plus 1. So in other words, you do get the 0 over 0. The next thing I want to mention is that we are in the second case, the case in which the inside of the absolute value is approaching 0. So that's it. We would evaluate both one-sided limits. The one-sided limits. But we don't need to do this because our limit is already a one-sided limit. So pretty much, if you didn't have that negative here, if x was simply approaching negative 2, like negative 2, then in this case, you would have to take both one-sided limit. But since I'm already asking for a one-sided limit, you just need to do that side, okay? But that's it. This is already a one-sided limit. So in that case, what you do is you take the limit, but now you need to use the fact that x is approaching not only negative 2, but negative 2 from below. So the first thing I'm going to do is I'm just going to copy paste the function, like 4 minus x squared over 2 over x plus 1 over x plus 3. Okay, you're going to directly substitute, and you already know that you're going to get 0 over 0. But the reason why you need to do it again is because you want to keep track of what the top is approaching. Okay, so the bottom you don't care because you have no absolute value here. Your goal is to take care of the absolute value. So at that point, you have like 4 minus, and here you're going to square negative 2 from below. Okay, at this point here, I require a little bit of imagination. Negative 2 from below, okay, corresponds to something like negative 2.00 all the way up. Well, it's not equal, but we're just informal here, right? So when you're approaching negative 2 from below, you're passing through like negative 2.1, negative 2.01, negative 2.001. So the numbers are looking like this. As you square this number, so you have like negative 2 from below squared. The key part of the problem is that you are getting a number that is above 4. Okay, and this is only because disregarding the sign, if you look just at the numerical value, it is bigger than 2. So when you square it, the result is going to be bigger than 4. So, and this is a crucial part in the problem, just to realize that the numbers that you get after squaring is a number that's bigger than 4. Okay? Now, this is what you want, because if you subtract a number that's bigger than 4 from 4, you're going to get 0 from below. And this is the information you need. So what does this mean? It means that the inside of the absolute value is approaching a negative, well, it's approaching 0, but it remains negative as x is approaching negative 2 from below. So as x approaches negative 2 from below, like 4 minus x squared, okay, stays negative. It's approaching 0, but it stays negative. And as a result, it means that you're going to replace so you have again the same limit, so from negative 2 from below. Now you're going to use that fact to replace it with negative the bracket. Okay, so because if it's a negative number, if it stays negative, the absolute value needs to turn it back positive. So that's why you multiply the 4 minus x squared by a negative sign. Okay. Now, keep in mind that at this point, the only thing we have done is to tackle the absolute value. We still didn't cancel a redundant factor. So there's no point in direct substitution here. We need to cancel a redundant factor. So at the top, this is easy. Okay. And okay, I'll go slow just because first of all, I'm in a YouTube video. I just don't want to skip like a step that might be tricky. But the denominator, we have to handle it. We have to be careful when we handle it. And okay, yeah, I know what I'm gonna do. So remember, whenever you have something like this, the idea is to multiply it. So you multiply both the top and the bottom by the common denominator. So in other words, by this x times x plus 3. So you multiply both the top and the bottom by that. Okay. Let's have a look at the result. Okay. Here you have x squared minus 4. And I'm going to factor it right away to x minus 2, x plus 2. And then I will do nothing with this x plus 3. So I will just keep it like this. The bottom is where the interesting stuff is happening, okay? Because what's happening on this term, what's happening is that you're canceling the x and you get what's remaining. So the 2 times x plus 3. Then the second term is the opposite, right? The x plus 3 cancels and you're getting plus, so just to be really lousy, plus 1 times x. Okay, so that's how you handle the complex fraction, like the fact that you have inner fractions at the bottom. Now, here, you don't want to do anything at the top. Don't go expanding the top. This would be a big mistake. Because, and I forgot the little, from below here, as I can see it. There you go. So, from there, you have the culprit. The culprit is right here. Okay, so your goal is to simplify the denominator to cancel the same culprit. All right, so from here, it's not hard to do, but again, I want to proceed like slightly slowly, just to make sure that you understand everything, because I know I cannot solicit your questions. So at the top, I repeat, don't do anything. Leave it like this. So x minus 2, x plus 2, x plus 3. At the bottom, I will start by just distributing and combining, and what you're gonna get is 3x plus 6. So 3x plus 6. And now you can see what's gonna happen. So that's it, x minus 2, x plus 2, x plus 3. And then, so factoring the 3 out, you get 3 times x plus 2. And from there, you won because you have the culprit here and you have the culprit at the bottom. So you cancel these culprits, right? You cancel the redundant factor that's giving 0. And only after doing that, you want to do direct substitution. Okay, so here, so I have here x minus 2. So I'm going to start off by having negative 4. Then I will have negative 2. And here I will have 1 divided by just 3. So I'll just write the answer at the top here. The answer is 8 over 3. All right, the full problem fits on the board, but slightly. As I said, I went a little bit slow. Normally, I would have like skipped that step and went directly there, but it's okay. Hopefully, this was helpful. And see you in class.